Have you ever wondered how your computer can play music, open websites, solve math problems, and run games all at the same time? The answer lies in one tiny but powerful component called the Central Processing Unit, or CPU. Just like your brain controls your body, the CPU controls almost everything your computer does. A computer program is really just a long list of tiny instructions. Every time you click a button or type a letter, thousands of these instructions are created. The CPU's job is to read them one after another and carry them out with incredible speed. The first step is called fetch. The CPU retrieves the next instruction from the computer's memory, known as RAM, or random access memory. Think of RAM as a giant library where all the instructions are waiting to be read. After fetching the instruction, the CPU must understand what it means. This step is called decode. The CPU figures out whether it needs to perform a calculation, move information, compare values, or do something else. Now comes the execute step. If the instruction is a calculation, the Arithmetic Logic Unit, or ALU, performs the math. It can add, subtract, multiply, divide, and compare numbers in tiny fractions of a second. Once the calculation is finished, the result is stored so future instructions can use it. Some results stay in tiny, ultra-fast storage areas inside the CPU, called registers, while others are saved back into RAM. The CPU repeats these 4 steps over and over again: fetch, decode, execute, and store. This process never stops while your computer is running and happens billions of times every second. Sometimes the CPU needs the same information again and again. Instead of going all the way back to RAM every time, it stores frequently used data in a tiny, super fast memory called cache. This helps programs run much faster. Modern CPUs contain multiple cores. You can think of each core as an independent worker. Instead of one worker doing every task, several workers can handle different jobs simultaneously, making the computer much more efficient. The CPU follows an internal clock that keeps everything synchronized. Every tick gives the processor an opportunity to advance its work. A CPU running at 3.5 gigahertz performs about 3.5 billion clock cycles every second, helping it process enormous amounts of information. When you launch a game, millions of instructions move from storage into memory. The CPU processes those instructions and coordinates with other components, like the graphics card and sound system. Together, they create the interactive experience you see and hear. Although it is only a small chip, the CPU is one of the most important parts of any computer. By continuously fetching, decoding, executing, and storing instructions billions of times every second, it powers everything from simple calculators to advanced artificial intelligence.
Thanks for watching Gubali, folks. If you enjoy the video, please like, share, and subscribe.